my amazing students. This is Mrs. A, and I love math. And this is Algebra 1, Lesson 1, and we're talking about fractions. So we're talking about reviewing how to add and subtract fractions with different denominators. Now, if we're adding or subtracting fractions that have the same denominator, we just add the numerators and keep the common denominator. So if we were adding 1/3 plus 1/3, that's no problem at all. We know that we have 2/3. We keep the common denominator. We do not add the denominators together. And this makes sense because 1/3 looks something like this. And the other 1/3 is identical to it and has the same pieces. So we have a common reference point. We say, okay, 1/3 plus another third is 2/3. And we could even take this third and slide it over onto that place, and in a perfect world, it would be the same, right? My drawings aren't necessarily perfect. But now, what do we do when we have different denominators? So here we have 1/3 and 2/5, which are not the same denominator. If we drew 1/3, it would look something close to this. And if we drew 2/5, it would look something close to this, because 2/5 means I have 5 equal parts and I'm selecting 2, and 1/3 means I have 3 equal parts and I'm selecting one of the 3. So when we start to add them together, we come into a problem because we don't have a common reference point like we did over here. We just said, well, that's 1/3 and that's 1/3, and they're the same thing, so now I've got 2/3. But here we have different sizes of items to start with, and so we go, okay, we can't add those together without doing a little bit of work. So we're going to get a common denominator. So we're looking for the smallest number that both 3 and 5 go into evenly, and that would be their product. Now I know it's the product because both 3 and 5 are prime numbers, and so the smallest number that they would both go into would be the multiple 3 times 5, or the product of 3 times 5. So we're going to end up with 15. So now I'm going to have to re-express each one of these originals over 15. Now 15 in the denominator means I'm taking the whole and dividing it into 15 equal parts, which we could do, but it would mean that this 1/3 would now, I'm going to divide each one of these little sections into 5 more sections. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so when I look at this, can you see it? This that was shaded 1/3 is now 5/15. Okay, so 5 out of 15ths would simplify to 1/3. If I divide the numerator and the denominator by the same number 5, wouldn't I get 1/3? So 1/3 is the same thing as 5/15, but now we're going to put 2/5 and express it as something over 15. So let's get 2/5 on here equals, so let's talk about some of the ways that we can do that without drawing a picture again. Okay, we could split each one of these into 3 parts, but that takes a little bit of time. What if we said 5 goes into 15 3 times? So we're going to multiply the denominator by 3, and then we have to multiply the numerator also by 3. So 2 times 3 is 6, and 6/15 is the same thing as 2/5. So now we have 5/15, which is the same thing as 1/3, and 6/15, which is the same thing as 2/5. And now we have common denominators, so we can add them together and get 11/15. And that is the answer. So we'll say 11/15 would be the answer there. Okay, and that is correct. So that's right at the top of page 1 in your book, and now we're going to come back with another example. All right, so now we have 2/3 take away 1/8. Again, we have the uncommon denominators, different denominators. We're going to have to get a common denominator to be able to subtract them. So we're going to say, what is the smallest number that 3 and 8 both go into? Well, 3 is prime. 8 is not prime, but 8 is actually 2 to the 3rd, which is 2 times 2 times 2. Okay, so even though 8 is not prime, we're going to have to multiply the two numbers together because they have no factors they can share. So 3 times 8 is 24. So we're going to have 24 and 24. So we'll erase that. We don't need that anymore. So now 2/3 is how many 24ths? Well, 3 times 8 gives me the 24, so 2 times 8 gives me 16. Okay, so if I simplified 16 over 24, wouldn't an 8 go into both parts? And when I divided both of them by 8, wouldn't I get back to 2/3? All right, so then we're going to do the same thing with the 1/8. What do we have to multiply 8 by to get 24? Well, it's a 3, isn't it? So 8 times 3 is 24. Therefore, 1 times 3 is 3. We're always multiplying by 1. So we're going to multiply this 1/8 by 3 over 3 to get 3 over 24. So now that we've gotten the common denominators, now we can perform the subtraction because we have the same denominator. 16 take away 3 is 13, and 13 over 24 is my correct answer. So we're on page 1 of your textbook. This one is the next example, and this one is made up of mixed numbers. A mixed number is when you have a whole number and a fraction added together. And when we're dealing with mixed numbers, again, we have our fraction part, and we're going to need to get common denominators. An easy way to do this is to go ahead and write your problem vertically, because then you have some room to write on the side. So let's go ahead and change this. Instead of a horizontal configuration, let's go ahead and take the 2 and the 1/8 and put it down here below the 13 and 3/5, and we're going to add vertically. And now, because we're going to add vertically, we've got room over here to do some work. So now we're going to change the 13 and the 3/5 into a corresponding mixed number that has a common denominator. 5 and 8 are the fractions that I'm going to have to add together. So the 3/5 and the 1/8 both will go into a denominator of 40. Again, 8 is 2 times 2 times 2, which is not a factor that 5 is in common with. So 5 times 8 is 40. We need to change this to 13 and something over 40. And then we're going to change this one down here to a 2. I better stick that 2 underneath the 3. And something over 40. So now let's do our little multiplication. 5 times what is 40? And 40 divided by 5 is 8. So 5 times 8 is 40. 3 times 8 is 24. And then on the bottom, 8 times 5 is 40. So 1 times 5 is 5. And you can see that if I simplified, I would go back here. If I simplified this fraction, I would go back here. So now I have the common denominators, and I am ready to add. 24 plus 5 is 29 over the 40. Remember, we always just keep the common denominator. And then 13 plus 2 is 15. Now this one does not need any simplification because my 29 is less than my 40. If when I added I got to a number bigger than 40, then I would have to simplify and bring a whole over here, which we will see before we finish up here. But this one is done and needs no further simplification. Can you see that board there? This one is the next example that they have there for you. Example D in my book. So now we're going to go ahead and write this in a vertical presentation here, just to make it a little bit easier and have a place to do all of our work. So now we're subtracting. So now we're going to have to do the same thing, get a common denominator. Well, we already did this same configuration except we added. So we already know this is a 40 and this is a 40. We know that that is going to multiply by 8 over 8. And I'll just stick it there for a second. 8 over 8, which gives me the 24 over 40. So we'll erase that now. And I'm going to go ahead and put my whole number in there too. Okay, so then over here, this one is being multiplied by 5 over 5, which is always 1. And so when we multiply by 1, we don't change anything but the form. So 8 times 5 is 40. 1 times 5 is 5. Just like we had before. We'll take that one out of there. And we will write the 2 down here in the front. And now we're ready to subtract because now we have a common denominator and we have 24 take away 5 is going to be 19 over 40. 13 take away 2 is 11. And so we have 11 and 19/40. Okay, so in both of those, we added, we subtracted. We didn't have any problems with carrying or borrowing. Nowadays, they call those renaming, but your book still uses borrowing, and that's fine. But just be aware that a lot of books will call that renaming, and we're going to come back with a problem that we have to do that on. Okay, so now we are again having to get common denominators because we cannot add or subtract fractions or mixed numbers that don't have common denominators. So now we're going to recall that this is going to be a 40 and a 40, 5 and 8. And then the 5 goes into 40 8 times, so 8 is going to be my multiple. 3 times 8 is 24. And 8 times 5, 7 times 5 is 35. Okay, so I didn't give myself quite enough room, did I? I need to write these down. So let's just draw a line so I can write them in there. So 13 goes right here. I should have left a little bit more room. Sorry about that. And 2 goes right there. So now I'm ready to subtract them. But I have a problem. 24 minus 35. Okay, so I'm going to get a different colored marker just so that you can see it. I'm going to pick up a blue one. So whenever this happens and we have a smaller number minus a larger number, we're going to need to borrow or rename. We're going to come over here to the 13 and we're going to take 1 away. So we're going to take 1 away from the 13, which makes that a 12. And we're going to add 1, but 1 will be in the form of 40 over 40. So we're going to add a 40 over a 40. And that's not a very good marker, is it? We'll go back to the black one. Right, so we're going to add the 40 over 40, and when we add the 40 over 40, what are we going to get? We're going to get a 64 over 40. So now we have 12, and I'm going to make this just a little bit smaller. 40 over 40 leaves me 64 over 40. So 64 over 40 take away 35 over 40 is going to be just a subtraction of the numerators and that's going to give me a 29/40. And now I'm ready to deal with my whole numbers over here. 12 take away 2 is 10, and 10 and 29/40 is my correct answer. Okay, 10 and 29/40. So there's your board for that example. Okay, so this next section that we're doing is 1B, and we're talking about lines and line segments. When we're talking about a line, we are talking about something that you would not be able to see in reality, because a line has no width and a point you can't even see. So it's kind of a theoretical thought. But your book is saying it has no width and no ends. So when we're drawing a line, we indicate that it goes on and on forever and ever in both directions. When we name a line, we can use any 2 points that are on the line in any order. So any 2 points and an overbar. So this same line, which has 3 points that are listed on it, a line really has an infinite number of points on it, because there's points in between those 2 points, an infinite number of points in between those 2 points. So a lot of theory here, okay, but we can name this line by using any 2 points and the overbar with the 2 little arrows to show that it goes on and on forever and ever and never stops, okay? And remember, a line has no thickness, so you really can't see a theoretical line, but we have to draw lines. And so when we're talking about lines, we will use this representation. So AX, AC, XC, CX, CA, XA are all different arrangements of these points. Any 2 points with the little overbar with 2 arrows going each direction, and that is the designation for a line. And then this is the designation for a line segment. A line segment starts at one point and ends at another, and the notation is going to be only the end point. So as far as a line, we could use any of the 3 because there is no end point. There are more points on this line than A and X and C, but we're just using those to designate the line. There is no end point. It never stops, but a line segment does stop. It ends at M and it ends on the other end at C. So we use an overbar with no arrows, and then we just put the 2 end points underneath the overbar, and that will be our line segment there. Okay, so we're going to do 2 practice problems, and then I'm going to let you go to do your homework. So here we have to add and subtract 3 fractions. So the first thing we're going to have to do is get a common denominator between 11 and 6 and 3. So the first thing I want to do is look for any similarities. Anything that might have a common factor. 11 is prime and 3 is prime, but 6 includes 3. So what we can do is we can just worry about the 6 and the 11 because the 3 is inside the 6 as a factor. So 6 times 11 is 66, and that is the smallest number that we can use as a common denominator. So we're going to take 66, 66, 66. We're going to rewrite each one of these over the common denominator. 11 goes into 66 6 times. 10 times 6 is 60. So basically I multiplied the 11 by 6 and I multiplied the 10 by 6 to get the new fraction. And here I'm going to multiply the 6 by 11, so I'm going to multiply the 5 by 11 and get 55 here. And then the 3 goes into 66 22 times. So 1 times 22 is 22. Now we're going to fill in our signs. We're going to perform the operations. 60, take away 55 is 5, plus 22 is a 27 over 66, and that will be our answer. So we just have to remember that we're subtracting, and then we're taking that 5 and adding it to the 22, and we keep the common denominator there. So that is an example for you. Very last problem of our section here on lesson 1. Now, I like the way they've done this because they've made it more interesting. So we have A, B, C, and this is a segment, not a line, because you do not see the lines going on, the little arrows showing a line. This is a segment. It stops and it can be measured. So it says line segment AC, which is the whole thing here, is 10 1/4. So 10 1/4. Okay, and line segment AB is 4 3/7. So this little part right in here is 4 3/7. And we are told to find the line segment length BC. So what are we going to do to get that done? If we want to find BC and we know the entire AC and we know AB, could we make this a subtraction problem and say, well, the answer is going to be 10 1/4 take away 4 3/7 is going to be the answer left over. So this one minus this one gives us this one, and that's what we need to do, isn't it? So now we've got a 4 and a 7. What would be the least common denominator between a 4 and a 7? Well, 7 is prime, and 7 and 4, we're just going to have to multiply them together and get 28. So we're going to use 28 here. And what I'm going to do is I'm not going to write the whole thing over again. I'm just going to rename the fraction here. So 4 times 7 is 28. 1 times 7 is 7. And then 7 to get to 28. I'm going to have to multiply by 4. 3 times 4 is 12. So just because I'm out of room, I'm not going to rewrite the 10 and the 4. So hopefully you understand what I'm doing here. So now I'm going to subtract. But notice they gave me a borrowing problem. I'm going to have to say, oh, 7 28ths minus 12 28ths doesn't work. I'm going to have to come over here and take a 1 away. So I'm going to take a 1, leaving a 9. That's going to come over here. And what am I adding here? When I take the 1 away over here, I'm going to add the 1 over there. But that 1 is going to be 28 over 28. So I'm going to add, I'm going to put it right there, 28 over 28. I should have left myself more room, and I did not. I'm going to come back and do that. Now we've got a cleaner board. So as we were saying, 7 minus 12 doesn't work. We're going to have to come over here, take away 1, make this a 9. The 1 is going to travel over here, but it's going to become a plus 1 in the form of 28 over 28. So now when I add the 7 and the 28 together, I have 35. So now we've got 35 28ths, take away 12 28ths. Okay, so we'll just make a little 35 up here so we can keep track of that. 35 take away 12 is going to be 23 28ths. And now 9 minus 4 is 5. And my answer should be 5 23 28ths. And we are done with lesson 1 of Algebra 1. And the first lesson of the school year is done, except for you need to do your homework. And this is Mrs. A, and may God bless your day.